Electromagnets. In this module, you will learn about electromagnets. You might have seen a crane lifting heavy loads of scrap iron. But how does a crane lift heavy loads? A crane has a strong electromagnet attached at its end. This electromagnet attracts all magnetic materials in scrap. You are introduced here to the term electromagnet. To find out what an electromagnet is, let us do a simple activity. For the activity, you need an electric cell, an iron nail, a piece of insulated copper wire, and some paper clips. Let us now start with the activity. Wrap the insulated copper wire tightly around the iron nail and attach its bare ends to the terminals of the battery. What do you observe? A current flows through the wire and the iron nail turns into a magnet. Now remove the connection. This will stop the flow of current through the wire and the nail will demagnetize. So, the iron nail behaves as a magnet as long as current flows through the circuit. Such a magnet is called an electromagnet. An electromagnet consists of a coil made from several turns of insulated copper wire wound on a magnetic material like iron. An electromagnet can be switched on and off and thus is also called a controlled magnet. Let us again consider the initial setup. Connect the iron nail wound with the insulated copper wire to two cells instead of one. You will observe that more paper clips are attracted towards the electromagnet. Thus, the strength of the electromagnet increases on increasing the strength of the current. Now, increase the number of turns of the coil on the iron nail. This makes more paper clips attract towards the electromagnet. Thus, you can conclude that the strength of an electromagnet increases with an increase in the number of turns of coil. Thus, the strength of the electromagnet increases on passing a larger current through the coil and on increasing the number of turns of the coil. Now, bring a bar magnet near the current-carrying coil or the electromagnet. You will observe that one end of the electromagnet repels the north pole of the magnet, whereas attracts the south pole of the magnet. What do you infer from this observation? This end is the north pole of the electromagnet. Remember, like poles repel and unlike poles attract. The other end of the nail is attracted towards the north pole of the bar magnet. This implies that this end is the south pole of the electromagnet. Thus, like permanent magnets, electromagnets also have two poles, north and south. On changing the direction of current in the coil, the poles of an electromagnet get reversed. Can you think of some devices of day-to-day use that use electromagnets? Well, electric motors, generators, electric bells, audio cassettes, speakers, and telephones are some devices that use electromagnets. In this module you have learnt an electromagnet consists of a coil made from several turns of insulated copper wire wound on a magnetic material like iron. An electromagnet is a kind of temporary magnet. It behaves as a magnet as long as current flows through the coil. The strength of an electromagnet can be increased by increasing the current or the number of turns of coil. Like permanent magnets, electromagnets also have two poles, north and south. Some devices that use electromagnets are electric motors, generators, electric bells, audio cassettes, speakers, and telephones.